Okay, the second topic about area under the curve and Riemann sum. We're gonna go with the definite integrals that I gave you on the last video, bonus on what Riemann sum is gonna take us to. We start with the general Riemann sum. Suppose that we have the intervals x sub 0 to x sub 1 and x sub 1 to x sub 2, x sub k minus 1 to x sub k all the way to the last interval, x sub n minus 1 to x sub n. As you can see, the graph shows it. This is my last interval. This is my first interval. And eventually we're gonna do the math and make delta x2, delta xk, delta xn goes to 0. And that's what we're gonna take you to. So we start with A all the way to B. And the numbers are aligned, as you can see, in order. Let delta xk, this right here, be the length of the subinterval as stated from here to here, and let x sub k star be any point in between. Then the Riemann sum reduces to this format: width times height, width times height, width times height, all the way. The height, instead of calling it left or right, we're gonna take it to a point inside. For the first interval, instead of saying f of x sub 0 or f of x sub 1, we're gonna say f of x sub 1 star. It doesn't matter where, because imagine if this delta x1 as a limit concept goes to 0. So you get my point. It doesn't matter anymore if we call it left or right. That is what we're doing, what we did in the last video, and this is called the general Riemann sum, instead of calling it left, right, or mid. Okay, let's be practical and see some examples. Here is 2x minus 6, and we're gonna go from 1 to 6. Here's a graph to help us understand. If you look at it, under the curve or the graph from 1 to 3, we are beneath the x-axis, but the height will be down. F of x1, f of x0, it's going to be negative. Applying it, just plugging in the numbers. So this will be reflecting or reflected using the integral as a negative number. This right here will be reflected by using the integral as positive, because we're using f of 4, f of 5 as heights, which, as you can see, they're above the x-axis positives. So what is the definite integral? That's the Riemann sum partitioning enough times where k goes from 1 to n. So we're partitioning it n times, but we want delta x to go to 0, or differently, n goes to infinity. This whole thing in a simple, elegant way, instead of writing the limit with the sum notation with the stars, we're gonna write integration. So the integration symbol, as you could see it, means the limit and the sum. We're gonna go from a to b, and delta x becomes too tiny. With the integration, after you apply the limit, we call it dx. Instead of calling f of x sub k star, we're just gonna call it f of x. So this is what and where integration started. Right here. Riemann sum, partition it enough times where delta x becomes 0 for each subinterval, apply the limit, write it in short, and that's called integration. So if you want to integrate 2x minus 6, that's this right here, from 1 to 6, you raise the exponent by 1 and divide by the new exponent. minus 6 becomes minus 6x. If you want to test it backwards after you simplify this, 6x will give you 6 as a derivative. X to the second, because there is no 2 anymore. Derivative of x to the second is 2x, as you could see. So that's the way we do it. I know we're not ready yet to use integration, but why not? It doesn't hurt. Do the math. Plug in 6 in this whole thing. Subtract, plug in 1 in this whole thing. Simplify your numbers and you get 5. So what is 5? Because you're not looking at the graph and considering or paying attention that this with the integration is going to give you heights that are beneath the x-axis, which is negative, you're going to end up with 9 minus 4 equals 5. Because that's going to reflect with integration using heights and bases with negative heights. Just be careful. We call it net area. If you need the net area, that's 5. If you need the whole area, you should consider 9 plus 4, which is 13. So the integration from 1 to 6 to x minus 6 equals the net area, which is a2 minus a sub 1, 9 minus 4, and that's 5. So what is 5? That's called net area. To support what I'm trying to say here, here's an example. Sine x goes from 0 to 2 pi, up, down, halfway at pi, down and back up to 2 pi. This and this are symmetric. This is above, this is below. Using the integration with heights, that's going to give you positive number, and that's going to give you negative number. And if you don't pay attention to that, you want the total area, that's going to cancel this, and the integration, if you do the math, from 0 to 2 pi without graphing, you're going to end up 0, and the graph shows why you end up with 0. This and this cancels each other. A positive number here, a negative number here, same amount, they're going to cancel. Let's take a different example to show you the concept of integration related to area under the curve. So in case they're asking you to find the integral from 0 to 4, I made a mistake here. 0 to 4 is this part only, not the whole semicircle. So I'm going to have to fix that. So let's take it from negative 4 to 4. If this is negative 4, because my graph, I can't fix my graph, I could talk about it, but let's take the shaded area. That will be, in a different language, find the integral of this curve from negative 4 to 4. If you want this area under this curve. But what is this curve? This is y. Y equals f of x, which is square root of 16 minus x squared. This is the top half of a circle. If you want the lower half, that's going to be the minus square root of 16 minus x squared. And if you want to see this is a circle, write it as y equals square root of 16 minus x squared, square both sides. I get y squared equals 16 minus x squared. And when you move the x squared, you'll end up with x squared plus y squared equals 16. That supports that the radius is 4. But since you want the half the circle, that should be half pi r squared, because we don't know yet how to integrate these. But if you know that what this is asking, it's asking for the integral or the area under this type of a graph. So half times pi r squared, which is 4 squared, do the math, it's 8 pi. So what is 8 pi? The area right here shaded. And that should be negative 4 to 4, not 0 to 4. Alright, let's take a Some examples about properties of integrals, which I'm not listing them here, but they're kind of easy to follow in any textbook. Here I'm trying to use examples and write less for the slides. Given the integral of f of x dx from 1 to 4 equals 8, and the integral from 1 to 6 f of x dx equals 5. Find the following. From 1 to 4, negative 3 f of x dx, and 12 f of x from 6 to 4. Let's take care of this one here. I could take the minus 3 outside. That's part of the rules, the properties of integrals. And this is given to me because I don't know f of x, but I was told from 1 to 4, f of x, that will give me 8. So that's negative 3 times 8, which is negative 24. Now this is a little bit different. There is no 6 to 4 here, but we're gonna use properties and do it. I'm taking the 12 out, and I see a minus sign. So I'm doing two things at once. That's what we call it, two birds, one stone. Sometimes we have to reduce the steps as long as we know what we're doing and we're not making mistakes. So what do I mean by two birds, one stone? 12 out, that's 1. Oh, notice that 6 to 4 now is 4 to 6. So in the integral from a to b won't be the same as from b to a. It's going to be the same amount but opposite with a negative sign. So that's the two steps in one, or two birds, one stone. 12 out, change this from a to b to b to a. Sorry, from b to a, switch them, but you need to balance it back by a negative sign. Alright, now that's much better to look at it from 4 to 6 instead of 6 to 4. How can I take advantage of these guys? Well, it looks like there is a 1, 4, 1, 6, so 1 is kind of like involved. But before I use the 1, I could do the following. The integral from 4 to 6 could be written as the integral from 4 to 5 plus the integral from 5 to 6. You get the idea, right? So you could take it as two parts and finish it. But in general, we don't have to go like 4 to 5 and 5 to 6. We could go like 4 to 5.1 and 5.1 to 6. And it doesn't have to be in the middle of 4 and 6. I could go from 4 to 3, then go from 3 to 6. That will cover the whole thing. So here we go. From 4 to 1, then from 1 to 6. If you add them up, that's one of the properties of integrals. That will make it from 4 to 6. Back to here. Okay, this one is good. It's right there. This one is not there. That's the other way around. So we need to flip this. When you flip it and read it from 1 to 4, you're going to have to use a minus sign. And that's what we have. Now, just regular math, or if you want to simplify it because it's my first example, I could write this up front, write this after, make it look neat, nothing more. From 1 to 6 minus 1 to 4. 1 to 6 is right here, and 1 to 4 is right here. Put the numbers in, simplify, and the answer is 36. Another example. Given from 0 to 1 as an integration of x cubed minus 2x with respect to x to be negative 3/4, we need to find these two values. Let's take care of the first one. Comparing it back and forth, I see some kind of similarity, but not fully exactly the same. So I could rearrange, put this up front, put this after, maybe so I could see what's going on. Oh, I see the -2, so I could take the -2 out as a common factor. And I think you see the whole package now. That's -2 times -3/4 or 3/2. Okay, let's take a look at this one here. Now I'm gonna do 2 steps in one. 2 birds, 1 stone. One more time. From 0 to 1. From 1 to 0. So I'm gonna switch them. That's gonna give me a minus sign. X cubed is negative x cubed. Negative 2x is positive 2x. So I'm gonna switch these, like apply a negative sign to both, flip this, apply another negative sign. That's gonna cancel both negative signs, and this is what I have. So I'm switching 1 to 0 to be 0 to 1, switching these or applying a negative sign to them. That's gonna balance the other negative sign, and that's what I call it, 2 birds, 1 stone. All right. I think you see the answer. There is nothing left to do. All right, it's the same thing as we have. All right. Now it doesn't hurt to see more ideas about what's coming. So I'm gonna call it bonus. Whenever I can, I'll just give it to you, because that's exactly what we're doing, integrating, paying attention to some properties, and move on. Here's a bonus. If f of x equals x to the 5th, what's f prime? 5x to the 4th. All right. If f of x equals x to the 5th plus a constant like 7. 7 is a good number, right? I should have written 711. That's my favorite number. So what's f prime in this case? I think the same, because 7 is going to be gone. It's going to be 0. So when I said earlier that integration is the inverse of differentiation, so how can I integrate from here, go back, and get this? Well, if I start here, I get this, I get it, but how can I go from here and get the 7 back? Well, this is the whole idea. So if you have the derivative and you take it back, you have to be on the safe side and write plus c. This is called the constant of integration. C could be 0, like in this case. C could be 7, like in this case. C could be 711, like in my case. So, in a different way, going backwards from f prime to f, we use the integration symbol, which is the limit of the sum as Riemann sum. That will give you f of x plus the constant of integration. Is it always there? No. If you have a definite integral from a to b, this one does not have any. When you plug in the numbers, c is going to cancel both ways, so we just write it without c, no c. The definite integral does not have a c. A general rule for integration that is useful and is used more than others is x to the power n. In derivatives, the derivative of x to the power n is n times x to the power n minus 1. The integration of x to the power n is x to the power n plus 1. You increase the exponent by 1, and you divide by the new exponent that you came up with. Then don't forget the constant of integration, because I don't have limits right here, a to b. So what's the integration of 5x to the fourth? You could take the 5 out of your way, increase the exponent, divide by the new exponent, but that's a 5, cancels the 5, and it's x to the fifth plus c. Try to test it back by finding the derivative. What's the derivative of x to the fifth plus c? It's just 5x to the 4. Okay. So what's the integration of a constant? If it doesn't have a power like this, a dx will be ax plus c. Test it. What's the derivative of ax plus c? Derivative of ax will be a, derivative of c will be 0, and it's just a. Let's take another bonus. So how do you integrate x to the fifth plus x to the third minus x to the second plus x plus 9? That's how you do it. Test it backwards. Derivative of c is 0. You don't see it. Derivative of 9x is 9. Derivative of x to the second over 2. 2 goes up front, cancels this, and stays with 1 less, which is 1. Right there. And the story continues. So you want to keep in mind that the integration of a constant like 9 is 9x. Sine derivative is cosine. Let's use integration to write it the other way around. That means the integration of cosine is sine plus the constant of integration, because I don't have limits right here. We know that the derivative of cosine is negative sine. So let's write this as integration. The integration of negative sine x is cosine x. And what about if you don't have a minus sign here? That means it shows on the other side. Alright, just be careful. To support, the derivative of sine is cosine, but the integration of sine is not cosine, it's negative cosine. You know, once you get used to it, you'll notice the difference and you could take a note out of it. Enough with the bonus slides. Let's go back to practical examples of properties of integration. So from 2 to 7, integration gives you 3. From 2 to 7 of g of x, integration gives you 7. Evaluate the following integrals. I have 4. Let's take care of one by one. This one is g, so I have to look here. 72, 2 to 7. I think you get the idea. So they're switching a and b, right? Minus 2 to 7. If you want to flip this, you have to put a minus, and that's not 7 anymore, negative 7. This is the property that I'm using. From a to b, f of x will be minus from b to a, f of x. That's the property. Okay, let's take care of another one. 2gx. 2 is in my way compared to this guy, so I'm going to take the 2 out. That's another property. 2 times 7, because that's 7 given to me, which is 14. This is the property that I'm using. If you have a constant, take it out of your way. G of x minus f of x, 2 to 7. You could break it down. The integration of the difference is the difference of the integration. 2 to 7. 2 to 7. G of x, that's 7. 2 to 7 f of x, 2 to 7 f of x. So it's kind of handy. 7 minus 3, which is 4. Subtraction, and a 6 in my way. So it's kind of like a combination of these two together. Break it down and take the 6 out, and plug in the numbers, and 39 is the answer. That should do it for this video, and I'll see you in the next one. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.